arms in the air and all of that. This is the, I think we decided, 4th or 5th week or event that we've held under the reconstituted Data Visualization New York. This is my co-organizer in the back here, Paul Trowbridge. So thank you all for coming. We have some fantastic speakers tonight. Andy Trice is going to be speaking about data visualization with web standards. And after that, two fine fellows from, do you pronounce it EPAM or EPAM? EPAM, okay, are going to be speaking about some fantastic work that they have done, and I'm going to let them tell you more about it. I'm just going to bookend tonight's presentations with two things. Thanks to Kinsey & Company for giving us the space and the refreshments. Thanks to our speakers. And thanks to all of you for sitting down and thinking about what can I do, what do I have to offer the group, what presentation do I have in the back of my head that might just need a little push to get it out and get it ready to share with this group. For those of you who haven't been here before, we cover just about everything, all angles of data visualization. Tonight is a very technical presentation. It's going to be focused largely on web and other electronic articulations of visualization, but on a month-to-month basis, we cover everything from statistics to the design and user experience of visualizations, to the technical parts of implementing them for the web or in other environments, to individual practitioners, social scientists, physical scientists, anyone who is collecting large data sets and then seeking to extract them and extract insight from them. So any of you, all of you are potential future speakers for this event. Short presentations, long presentations, whatever would suit you best. 5 minutes even. We're very happy to just have 5-minute talks, lightning talks on your latest project, something you find interesting, or whatever else. So just let us know. It's great professional development. It's great networking. It exposes you to a bunch of your peers in a very positive way, and contributes to the discussion, the quality of the content that we have here in this group. So without further ado, I'll leave it to Andy, and I think Andy will be able to take a couple questions when he's finished. But we'll go from there.
All right.
Thanks.
Well, thank you, everybody. Thank you for having me, and thank you to Paul and Christian for putting everything together. My name is Andy Trice, and I'm a developer evangelist with Adobe. And whenever I give a presentation, I actually like to treat them as conversations. So at any point in time, as I'm talking about data visualization with web standards, if you have a question, feel free to raise your hand, interrupt me. Because what I've found is that through a lot of these presentations and the conversations that we have with people, really great topics of conversation come out of this. So, you know, there might be something that someone on this side of the room has a question about, which spurs a question from this side of the room. Next thing you know, we're all engaged, we're all talking, and great ideas come out of that. So, I'm here to talk tonight about data visualization with web standards. And so, let me go ahead and get started. Data visualization. I don't think anyone would be in this room if they really weren't aware in some fashion of what data visualization is. But let me take a step back. Instead of focusing on the data visualization, let me try and figure out where everybody's coming from. So how many people in the room would consider themselves from a developer background? Okay. How many people are coming from like a design kind of background? Okay. And how many people would think they're coming from, characterize themselves as like a scientific type of background or mathematical? Okay. So it's a nice mix. I would say with a little bit more designer and developer than mathematical. So the content of my presentation is going to be fairly technical. I'm going to talk about kind of the nuts and bolts of how you create interactive visual scenarios, essentially, that allow you to represent data inside of a web browser. I'm going to talk about the underlying technology, the techniques that you go about building these types of interactions, making them rather than static, actually interactive, so that people can do fancy things with them. But I'll try not to get so technical that the people who aren't necessarily technically focused don't understand what I'm talking about. So with that said, data visualization to me is a visual representation of data information. It's a way to put together shapes or numbers or whatever it is in a visual fashion to clearly express an idea. So the whole content of this presentation, I'm trying to focus on that idea of putting together shapes or textual elements or something to create a visual piece that explains information to whoever your target audience is. Now, as I have up here on the screen, some of you may be wondering, why is this guy from Adobe talking about HTML? Don't they have Flash? Okay, yeah, a couple people laughed, so you know what I'm talking about. More people laughed, okay, then more people know what I'm talking about. But let's take a step back and look at the history of computation, a modern history, so just what's happened in, let's say, the last 5 years. Retrospective. Flash used to be the only really good way of creating interactive data visualization on the web. Even 5 years ago, the capabilities of HTML weren't there. And just so I'm clear on this, is pretty much everyone familiar with just what HTML is? Okay, I see a lot of hands. That's good. Otherwise, I'd have to take a step back. But Flash, you can create some really highly visual interactive scenarios. Like there's a lot of really cool things that you can do with it. And what's interesting is the roadmap of Flash right now is targeting a premium video and a premium gaming experience. So you can create like super high-end these interactive experiences. But what we're starting to see is that's as mobile devices proliferate, it's not available on all those different platforms. And so, as a company, we've started investing more heavily in HTML and HTML-related tools. So, thinking back still on the Flash side of things, how many people have used this chart? That's all the hands, really? Okay, how many people have tried to rebuild this chart on their own? Okay, I've tried to do it too. It's kind of fun. But this is Google Finance. This was a hugely popular Flash-based data visualization for financial information. Still huge today. Lots of people use it all over the place. Here's an example of data visualization piece. And the examples I'm going to show you, some of them I put together, some of them I did not put together. With Adobe, I'm not with Google. I didn't write the Google Finance chart. This is a data visualization that's a Flex application. And Flex is a framework for creating programmatic application experiences on top of the Flash platform. It was put together by a team at, I guess they're IBM now, iLog. They have visualization components. This is all based on Flash platform, so we have lots of nice fancy charts and effects and things like that. It's still a great interaction. But as I said, technology trends have shifted. About 6 years ago, there was a device that was introduced to the market that changed a lot of things for a lot of people. So with that, I mentioned times have changed. Not all mobile devices support Flash. And what's interesting is if we start to think about devices as computers instead of just as a phone or a tablet. Okay, let's not even take the phone into consideration right now. If we take about the tablet into consideration. In Q4 2012, I think it was Q4 2012, if you include the iPad in the total computer sales for that quarter, I think it was iPad, there's a staggering statistic where I think it was like 1/4 of all PCs sold in that period were iPads. They were iOS tablets. So this is like a huge player in the game. We have to create experiences that are going to run everywhere. They need to run on tablets. Whether it's iOS, whether it's Android, because another interesting thing is that the two predominant operating systems for mobile devices right now are iOS and there's Android. And even on Android devices, if you're targeting Android 4 and later, which is the latest version of them, there's not a version of a Flash player to run on that. No, you can use Adobe Air, which is a tool for building natively installed mobile applications to do highly interactive visual type of experiences as natively installed apps, but that's not going to run in the browser for you. So if you want it in the browser on these mobile devices, you need to go with an HTML-based approach. During this time, actually the capabilities of HTML have changed. How many people have heard or are familiar with the buzzword of HTML5? Okay, just about everybody. Then, how many people have actually sat down and kind of studied what exactly is HTML5? What's this buzz all about? Like, what does it really do? Okay, so HTML5 is an evolution of the HTML language. So HTML is a declarative markup language that's generally used to structure information on the web. And, if you think about the structure of a web page in memory in the browser, it makes up your DOM, which is your document object model. And HTML5 adds some really interesting capabilities. So it's not just about static textual content. It's also about adding interactivity. So you have things like the HTML5 canvas, which is a programmatic drawing surface. You have an SVG, which has become a part of the HTML5. It's kind of lumped in under the HTML5 umbrella. But that's for scalable vector graphics, which I'm going to get into these in a little bit more detail in a moment. You also have to think about there's new JavaScript APIs that might reflect with geolocation. There's CSS3 styles. There's all these things under HTML5. But the point that I'm getting to is that HTML5 as a platform itself has evolved in order to be able, and it allows us to be able to create really highly visual, highly interactive, like rich types of experiences that are totally dynamic and totally change on the client side without having to do like round trips to a server. So why else is an Adobe guy here talking about HTML? It's because we love HTML. We have a new line of tools. So the Adobe Edge suite of tools and services are tools that are focused entirely on developing app experiences with HTML. Now, I'm not going to go in depth on all these different ones, but we have everything from timeline-based animation to responsive design tools to code editors, synchronized. Edge Inspect is cool when it's a synchronized browsing experience across different mobile devices, so you can drive the experience from your desktop on an array of mobile devices, so you can do a synchronized testing experience. Edge Web Fonts, Typekit, both about typography and very visual and types of experiences on the web, and also PhoneGap Build. So that leads me into Adobe with HTML and mobile applications. So PhoneGap is a tool that allows you to build natively installed mobile apps, so they can be deployed through like the App Store and things like that, using HTML and related technologies. So the techniques that I'm going to talk about can be used with these tools, can also be used with PhoneGap to create both experiences targeting the web, so mobile web, desktop web, but can also be used to target natively installed mobile applications. Adobe also contributes to the development of the HTML5 spec and web standards. So we actually have a web platform team that all they focus on is helping evolve the web forward, push the web forward, and evolve the capabilities of the browser based upon the experience that we've learned with the Flash player. And this is everything from CSS regions and CSS custom filters, which are like highly cinematic visual type of effects, CSS exclusions, so nonlinear shapes. So, and that's really interesting also, like CSS exclusions and regions can be used to have basically text from one piece of the screen flow into another piece of the screen inside of a non-standard shape, and you can use that to create interesting visualizations also. But I'm not going to go into too much detail on that. But here's an example that I wanted to show, and this is the last part of the Adobe products I'll talk about before getting the underlying technology. But this is kind of a simple data visualization sample that's available. Oh, and one other thing, all the HTML tools that I talked about are freely available. Well, most of them are freely available on html.adobe.com, but you can go and check those out if you want to. But here's an example that was created using Edge Animate, which is a timeline-based animation tool for HTML experiences. And I'll go ahead and click on North America. It's going to zoom in, and it's going to do a small chart that you see here on the left-hand side. And this is mobile browser market share. I don't remember what the date they actually captured this data was for. But this is an interactive experience that you can see. It's animated, it's visual. I can go and click on different regions. The data zooms in and out. But this is entirely built with, it's visualized in HTML, CSS, JavaScript, and it's built using the Edge Animate tool. So I just wanted to show you that to kind of give you an idea of what you can do with the Adobe tools. And now I'm going to start talking about the underlying technology. So I mentioned that, how do we actually go about visualizing data? And let's start with the most primitive aspect of getting information on the screen in a non-text format, and that's an image, a standard image tag. Anyone who's done HTML before has probably used the image tag, and basically what you're doing is you're requesting data from a server. You hit a URL, it returns you an image, you can do it dynamically generated from the server. But you know, there's not a lot of wow factor to this. It's not interactive. It requires a server round trip. Like I said, there's no wow. An example of it is the Google Image Charts, which is actually deprecated. They're not going to continue supporting it going forward. But this is the most fundamental aspect of how do you start displaying information. Nobody gets excited about this. It's been around since the 90s when the internet came to be. And it also doesn't work in things like offline scenarios, where if you have a natively installed app that's built on web technology, you can't use it on there if you're offline. So let's talk about the HTML5 canvas. Now, how many people have actually tried to use the HTML5 canvas so far? Okay, good number of people. So you guys already know at least a bit about what I'm going to talk about here. So the HTML5 canvas is exactly as the name implies. It's a canvas, so in this case, we have the canvas tag. And what it is a blank canvas on the screen. If you were to just put a canvas and not put any script behind it, you'd have just a blank rectangle. And what it gives you is a programmatic drawing API so that you can do basically down to pixel level manipulation of the content within that canvas. So if I wanted to say, I want to draw a line from point A to point B, or if I want to draw a curve, or if I want to draw a circle, you know, I can do that. And basically what happens is you play a complex game of connect the dots, and then next thing you know, you're rendering very complex, very intricate shapes. And that's essentially a foundational building block into creating interactive data visualizations. What's really interesting about this is it's totally client-side rendering. And when I say client-side rendering, I mean everything that is visual in this is actually rendered in memory inside of the web browser. So once you have your application experience loaded in the browser, you don't have to have, let's say, a request to a server in order to cause this to redraw. If you have the information in memory, you can have it redraw. And that gets really interesting if you're in kind of like offline state. But it also makes it so that it can respond to input. So if you're clicking on an element, or you want it to animate based on data that's coming in real time, or if you want it to, I don't know, it can get as complex and crazy as you want. I'm talking about the data visualization kind of scenario, but if you've ever seen a lot of really highly visual interactive HTML games, a lot of them use HTML5 canvas, and you have characters running around the screen, explosions, whatever. It can be a very, very powerful medium for interactive graphics. So as I mentioned, it's a programmatic drawing API. You can use it to draw circles, draw arcs, or basically the same thing, draw lines, draw quadratic or cubic Bezier curves. You can also get down to setting at the individual pixel level. So let's say if I have 200 by 200, I want to say, oh, I want the pixel at 50 by 50 to be red. And if you're getting down to that really low level pixel level manipulation, you can get very, very, very fast processing speed and render a lot of data that you might think unimaginable in the browser. So I mentioned it's very dynamic, it can work in offline scenarios. And an example library that uses this is rgraph. Has anybody used rgraph? Okay, a couple people. It's essentially a chart visualization library built on top of the HTML5 canvas, which allows you to do dynamic client-side rendering. So you don't have to build the chart yourself. You can leverage a library that already does a lot of this for you without having to come up with the custom graphing logic on your own. But if you did want to do it from your own, the basic way to do this is the top left corner is your registration point. This is 0, 0, just like most other languages in computer graphics. If you want your data to be displayed across this square, based upon your data values, whatever range you want to put it, if it's a bar chart, column chart, generally you want to swap the axis so that your registration point is down here. It's a little bit of math you have to do to switch things around. But then you can start drawing, and if you want a column to be 100 pixels tall, you draw it from here to here. The next column, you draw it here to here, here to here. Next thing you have a bar chart. It's actually, once you start putting the pieces together, it's really easy to create some interesting visual experiences. Now, I mentioned a bar chart, well, a column chart in this case, and here's the code that does it. I've kind of cut out all the specific stuff where you have to get a reference to the canvas first, but this is JavaScript, and what I'm basically doing is I'm looping over an array. For each data point, I'm calculating the x position, which is the increment, which is the number of columns. I'm calculating the height, which is the height based upon the data that's passed in. And I'm calculating the offset from the top, because we want it to be aligned along the bottom. And then once I have the x position, the y position, and the height, I'm going ahead and just filling a rectangle and then doing a stroke rectangle based upon the x position, the y position. Then, okay, the width, which in this case, there's a little calculation happening here to programmatically determine how wide I should make it. And then the actual height of the bar. So just by looping over this, doing a really fairly simple operation, it's gone ahead and programmatically created this column chart that you see right here. And this is, so I haven't stuck an image in there, that is an HTML5 canvas. And it's really easy once you start putting the pieces together in your mind. How do I script this? How do the different pieces go together? How I can start making some really complex data visualizations. Now what's also interesting here is, I haven't built it into this example, but what if I wanted to if I mouse over a certain area, or if I'm on a tablet and I want to touch a certain area, I can calculate based on the XY coordinates, what am I hovering over? And then I can cause it to redraw just the area that I'm hovering over, and you can start adding some really rich type of visual effects. Some really cool things can happen there. Here's another example where I tried to make a really basic scatter plot. And what I did was take literally the exact same example, but rather than, and all the data is randomly generated, just in the browser here. So what I did was take the exact same example, and rather than drawing columns, I gave each data point both an x and a y property. X and y. And then all I did was calculate, based on the range here, where should a circle be drawn for each given data point. And all I'm doing is setting begin path, which is part of the HTML5 Canvas API. And that leads me into another kind of topic. With the canvas, you can set what are called paths, which is a series of instructions that once you fill them or once you stroke them, it will go ahead and it will render everything that you've put into that path. So I'm beginning a path, then I'm drawing a bunch of arcs, so a bunch of circles. I'm setting the XY position, setting the radius, and then also saying it draw a full 360 degrees. And then once I've looped over all of them, or excuse me, for each iteration of the loop, draw the arc, I fill it, I set a stroke on it, and that ends up with what you see here. So there's kind of a light semi-transparent red, looks kind of pink with a black stroke around it. And now there's other code in this example where I've looped over and put some grid lines in based upon the range here. I think the ranges in them were from 0 to 10 or 1 to 10. But you can get the idea that using a very simple set of instructions, you can programmatically create visual elements that can be used to create a much more complex picture. Now, these are really, really basic examples of a really simple column chart, a really simple scatter plot. But now let me show you something else. So this is an example I put together just to kind of see how far can we push a HTML5 canvas. And what it is a scatter plot that has 10,000 data points. This is totally rendered inside the HTML5 canvas. And it's not only a scatter plot with 10,000 data points, but we've also got a histogram so we can see the density of the distribution of each individual point. Now, this is totally rendered client side. And what's kind of cool about this is I can also go ahead and let me just zoom in. You can see I can redraw. I'm zooming on different pieces of data. And when I say we can make things interactive, like this is what I'm saying, where you can make it very, very interactive. So basically, just by clicking on it, I'm gathering XY positions, and by knowing the range of data that is in my current viewport, I can say, oh, I can determine if I have a rectangle from here to here, and I know that this one is from 39.3 to 45.38, calculate the percentage of this X position corresponds to 41 and some change, or whatever, and you can then zoom in on that particular area. You reset the viewport of where you're trying to draw and just redraw it. And the way that I'm able to render that many pixels that fast, if you're trying to do like move to line 2 or draw rect or draw arc, you're not going to be able to do 10,000 data points because the instructions that it takes to render all that would be very computationally expensive. When you want to get really high performance, this is a case where I'm setting individual pixel values. And I can jump into the code for this. But before I do that, I want to actually show another instance of this. So how many people think 10,000 data points is a lot to render in the browser? Okay, not that many people. Oh, come on. I thought I had a better example than that. How about 1 million? And I can also take that and zoom in. And so all the data for this I've actually randomly generated with a bias to 0, 0, so it's more dense down here as opposed to, what I put it, 100 by 100. But basically, if you have real meaningful data and not my randomly generated mess, you can start to get a very, very powerful visualization type of scenario. It's highly interactive. You can drill down into it. Oh, wait a minute, look, it works in a web browser, so if I put it on a server, all of the billions of machines that are connected to the internet, as long as they support HTML5 canvas, can now interact with this. That means it runs on my iPad, it runs on my desktop computer, it runs on my Android tablet, it runs on my phone. Now, 1 million data points might tax a phone, don't doubt that. But this actually runs really well on, I have an iPad too, it runs great, even the 1 million data points example. The longest part of it is actually generating the data, and if it was using real data, the longest it would take for 1 million data points is actually serializing that data to the client, so getting that data onto the client so it can be rendered, not the actual rendering process. So, does anybody want to jump in and see the code, how that works? Okay. And I'm going to be making this, well, most of this presentation is actually already on my blog, but I'm going to be making this presentation available on my blog also, so that if you want to see all of it, it's free to download. You can check it all out. So let me jump over to... So I mentioned Adobe has some tools. This is Adobe Edge Code, which is a HTML code editor. Actually, let me jump back down here. And pause the jump. So this is the 10,000 data, or no, sorry, that one wasn't 10,000, that was 50,000. Is that more impressive than 10,000? Okay. So you can see when it initializes, I'm just looping over 50,000 iterations, generating a random value for each point between X and Y. And there's not a lot in my actual HTML, or my... Can you guys read that, first of all? So, I'm generating the data randomly. If I scroll down, if I don't do it too fast here, you can see that in here, where is my chart? Oh, I must be creating it programmatically. I haven't looked at this code in a while. But let me actually jump to my chart here. Okay, so here I have it. I'm generating some HTML. Inside that HTML, I have different labels. I also have a chart here somewhere. Sorry, my canvas. So here, and then in this example, I'm using jQuery. So jQuery is a library that allows you to easily manipulate the HTML DOM without a lot of extra scripting. It abstracts some of the complexities between browsers away from you, so you don't have to worry about it. So what happens here is I'm actually creating a canvas instance just by generating an HTML string, creating the canvas, appending it to the HTML DOM, and then I'm calling my render function. And in my render function, it'll go through a couple steps. So here's my render function. The first thing that it does is we get the width and height. We calculate the actual chart width and height because if you notice there's a border on either side that's used for labels and also for the histogram. Sets a fill on it that's completely white. And then I'm getting, I don't remember why I've done that. But it goes through a couple different steps and it'll put in the grid lines that were used in the, as the background of the chart. Let me jump back over here so you can see. So